Most people think AI agents are just smarter chatbots, but that's completely wrong. Modern AI agents can search the web, use tools, remember information, and take actions automatically. They don't just answer questions, they plan tasks step by step, reason through problems, and make decisions dynamically. Hello friends, welcome to Agentic Navigator. In this module, you will build the strong foundation required to understand modern AI agents properly. So first, what exactly is an AI agent? An AI agent is a software system that can plan, reason, act autonomously, and learn continuously. You can remember it as PRAAL framework. With the help of this PRAAL framework, you can very easily understand all the core components of an AI agent required for its functioning. Let's now understand first core component, LLM as the brain. To understand this, just think, how can an AI agent plan and reason? It needs brain to think. That's where large language models, LLMs, come in. Models like GPT-5, Claude Sonnet, and Gemini act as the brain of the AI agent. AI agent uses these LLMs to understand goals, reason through problems, make decisions, and generate intelligent responses. Now let's come to the action part of an AI agent. How does an AI agent actually take actions? If an agent is given a goal or task, it shouldn't just respond with text. It should be able to act autonomously and execute the required steps on its own. That's where tools come in. Tools help your agent to act effectively on the given task. These tools can be browser, files, database, email, and APIs. So, with the help of these tools, your AI agent can now act autonomously for a given task. But now think about this. What if your AI agent has access to tools and APIs to perform actions, but there's no standard way to call them? Will the agent consistently get the correct results? Of course not. Every tool could behave differently, use different formats, or expect different inputs. That creates chaos for AI agents. That's exactly why Anthropic introduced MCP, the Model Context Protocol. Here, context means your system prompt, API result, and other tools, shared in a standard way. MCP provides a standardized way for AI agents to connect with and call external tools, APIs, databases, and systems. We will soon have a detailed video on MCP, where I explain it step by step. Now imagine this. You ask your AI agent to fetch some records from your company database. Will the agent automatically know that data? Of course not, because the LLM powering the agent was never trained on your company's private data. And this is exactly where another powerful AI technique comes in, RAG, or Retrieval-Augmented Generation. With RAG, the AI agent can first retrieve relevant information from your databases or enterprise systems, and then use that real-time context to generate accurate answers. We'll explore RAG in much more detail in an upcoming module, from complete architecture to real-world implementation. Last component, learning. So how can an AI agent actually learn continuously? That's where memory comes in. This is very important for agent to keep track of everything. AI agents use two types of memory to learn: store and recall required data. The first type is short-term memory, also called working memory. It stores recent chat messages, reasoning steps, and temporary information needed right now. The second type is long-term memory. This memory persists across sessions, allowing agents to remember users and learn over time. It has three subtypes. First, episodic memory. This stores past experiences and interactions. Second, semantic memory. This stores facts, concepts, rules, and preferences. And third, procedural memory. This stores workflows and task execution knowledge. Have you ever wondered how AI models become more helpful and align with humans? Your AI agent may sound smart, but without proper learning and feedback, it can still give poor decisions. That's where HITL comes in. Human in the loop. The AI learns from human preferences and becomes smarter, safer, and more useful over time. Frameworks like LangChain and LangGraph provide very powerful option to configure human in the loop, and we will soon see in upcoming modules. Not all AI agents work the same way. Some agents simply react to inputs using predefined rules. Goal-based agents can analyze objectives and decide how to achieve them. Learning agents improve over time using feedback and experience. And modern AI is rapidly moving toward multi-agent systems, where multiple agents collaborate together. Now you understand the foundations of AI agents. But real AI systems are built using powerful frameworks like LangChain, LangGraph, Crew AI, and AutoGen. Subscribe so you don't miss the next module, where we'll explore these powerful AI agent frameworks and see how modern AI systems are actually built. Hope you now understand the fundamentals of AI agents. Thanks for watching, and I'll see you in the next module.